In this video, we're going to work with a quadratic function and make its graph. We're going to graph a given function that is in vertex form. We're going to graph 5 points on the function, as well as the axis of symmetry. So we see we're given here y equals -1/2 times the quantity x plus 2 squared plus 3. And we are going to start by finding the roots of the function, the zeros of the function, also known as the x-intercept of the function. So when I say x-intercept, a knee-jerk reaction for that is that y equals 0. So I'll be able to rewrite this function as 0 equals -1/2 x plus 2 squared plus 3. And now we're going to just get x by itself. I'm not going to expand this square, okay? I'm actually going to work backwards to find x. Okay, so in doing that, I'm going to subtract 3 from both sides, and that's going to give me -3 equals -1/2 times the quantity x plus 2 squared. And then I'm going to undo the multiplication by -1/2 by multiplying both sides by -2, giving me 6 equals the quantity of x plus 2 squared. And then from there, the most pertinent step here is to square root both sides, remembering under all costs that when I'm solving an equation and square rooting, I have to come up with the plus and minus roots. So that is going to give me just a quick switch of sides here. X plus 2 equals plus or minus root 6. Then from there, I'll subtract 2 from both sides, and that will give me -2 plus or minus root 6. And this is root 1 and root 2 for this function. They're exact values. If you notice that they're going to be radicals, so on the graph they'll be decimal values. So I'm just going to go to my calculator and build approximations for them by doing -2 plus the square root of 6, and then second enter so I can save myself some typing, -2 minus square root of 6. Okay, so I'll just take a quick screenshot of that. And we see here that the roots are roughly 0.45 if I round to the 100. Oh, excuse me. Little tool malfunction there. -4.45 if I round that again. Okay, so it's good for us to say what the exact roots are, but then use our calculator to find approximations so we can find out where to put the dots. Okay, so from here, we're going to go with the vertex, which is really super easy to see given that it's in vertex form. Again, vertex form is y equals a times the quantity x minus h squared plus k. And then we've seen enough of this that for the h value, we reverse the sign that we see. So h is going to be -2, and k is going to be 3. So I just go to -2 comma 3 and put the vertex point. From there, the axis of symmetry is kind of academic. It's just given from the formula x equals h. In this case, it's x equals -2. which is a vertical line, a vertical line through -2. Now, I'm going to find the y-intercept. The y-intercept, every time I hear y-intercept, I think x equals 0. So I'm just going to compute f at 0, which means plug in 0 for x in the original function and simplify to find y. This will be -½ times 4 when I do 0 plus 2 squared plus 3, which is equal to -2 plus 3 is equal to 1. That means that I'm going to get 0, 1 for the x-intercept value. And using a little just basic symmetry, the reflected y-intercept is just going to be 2 grids away from the axis in the other direction, and it'll share the same y value as the y-intercept, which makes it -4, 1. Okay? Then just trying to, as best freehand as I can, draw something that looks like a parabola, and there you have it. So, just trying to box in and highlight some of my answers here. We have that I've circled the x-intercepts. Okay, we want to put a box around the axis of symmetry to show some attention to that to the teacher, as well as the vertex. And I've already boxed in the y-intercept and the reflected y-intercept. Okay, the meat of this process, again, the review, is done right in here. It's where we find the x-intercept. Again, for the rest of your life, you have to think when you hear x-intercept, y equals 0. So I just put in a y equals 0 and focus on solving for x. This is just some good old-fashioned get x by itself, undoing operations that I see, and the only trick is kind of right here. It's when I am offered a quantity squared. Instead of squaring it out, I work backwards with a square root. And again, making sure that I get a plus or minus when I do that square root. Maybe the only other curveball here is that my 2 roots here have a radical in it, so I needed to go to my calculator to estimate those values, so I knew where to put them, on the graph. Okay, feel free to watch again if you'd like. This is making the 5-point graph of a quadratic when that quadratic is in vertex form.